Welcome and hello. This is a video exercise using HEC HMS. And in this exercise, we're going to be dealing with parameter estimation using the expression calculator. If you go ahead and click the link in the description, that'll bring you up to this website here, which shows the title of the exercise. They're calling it Applying HMS GIS Parameter Estimation Tools. So go ahead and click that link. What we have first is a page to introduce the topic. And then after that, compute subbasin and reach characteristics. And then finally, estimating parameters with the GIS dataset. So let's click on this first link together and just scroll through. As it says, this is an introduction to the topic with a background, overview, and a couple screenshots to what we'll be seeing later on. At the bottom of that page, there's a link here, continue to the computing subbase and reach characteristics. So go ahead and click that. Now what we need to do first is download these initial project files. So this zip file here, go ahead and click that and then click the download link. Okay, so that's almost done. Okay, so that downloaded. Go ahead and close that window. And then I'm going to open up that zip file that downloaded. We have a PUX Basin characteristics directory, and then inside that, a PUX directory. These are the files and folders I expect to see in my HMS project. I'm going to go ahead and move that over to the location on my computer. I want to keep it permanently. Then once that's copied over, I'll just delete the zip file. All right, so I'm going to open up the HMS file inside this PUX directory. Let's go to HMS, open project, and then click the browse button. Okay, so here I have my project directory, and then here's the .hms file. So I select that, click the select button, and now I have my project that's up and loaded. First thing I like to do is just expand the basin model and then get this onto the screen here so we can see what we're dealing with here. We have 3 separate subbasins on the map, as well as a junction and then our reach. The first thing the instructions tell us to do is click on parameters, characteristics, and then subbasins. So if we click on a subbasin, for instance, we have the different methods down here in the components editor. And then for each method, we have a tab that has the different parameter values specific to that selected method. So for instance, for the transform method, we've selected mod Clark. So the transform tab up here has mod Clark specific parameters, which we're going to edit. Also, if we go back to that subbasin tab, I want to direct your attention to the loss method, which is deficit and constant. So once we select that, then up here we have a loss tab, and then these 4 parameters are specific to that selected deficit and constant loss method. All right, so I'm going to go back to the subbasin tab here, and then what we're told to do is go up to the parameters menu, and then select characteristics, and then first subbasin. Actually, let me go ahead and unselect that subbasin. That looks better. So I'll go parameters, characteristics, and subbasin. It's calculating right now. Okay, so it made the calculations to bring up these numbers. And what I'm seeing on the screen here is a table with 3 different subbasins in our map, which are labeled in this far left column. And then in the rest of the table, we see the different subbasin parameters that can be used in the expression calculator, such as the longest flow path length in miles, the longest flow path slope in a decimal format, and so on. So you can just go ahead and read all these if you want. I also have a lesson on my lessons playlist for HMS that describes what these data values are. So I'll leave a link in the description. That's lesson 14, titled Basin Characteristics, Parameter Estimation, and Coordinate System. Now we need to make the same calculations for the reach. So I'll go ahead and close that window and then go up to Parameters, Characteristics, and Reach. Now there's only one reach in our map, and I guess it automatically calculated already. So those are the different reach parameters. All right, let's go back to the instructions. Now, if we just scroll down to the very bottom, we have a link to that second page, and this is where most of the work in this exercise is going to take place. So go ahead and click that link to continue to estimating parameters with GIS datasets. And now we're going to follow these instructions, starting with the transform parameter estimation. What it tells us to do is first select the basin, which we already have on the map here, and then select the parameters menu, transform, and then mod Clark. This is going to bring up a global table, a global summary table of all the subbasins that are using the mod Clark method, which is true for our 3 subbasins in our watershed. As you can tell, these parameters are not initialized for time of concentration and storage coefficient. So we can just go ahead and type the values in here if we want, or what we're told to do is to use this calculator right here. It's an expression calculator, which will quickly and easily populate these values, which would be probably the best and most efficient way to go, especially as we have more and more subbasins. So I'm going to move this over here, click the calculator button, and now we have our expression calculator. In this dialog box, we have the field right here at the top that we want to select. This refers to the two different parameters that we're going to be calculating. So if I select time of concentration up here, I have a time of concentration labeled down here just above the calculator expression window. And then if I switch it to storage coefficient, then we're calculating the storage coefficient. Once I have an expression in this text area right here and I click calculate it, then it would populate that expression or that column in this table for each subbasin. Also in this expression calculator, we have our variables, which can either be grids or statistics. And then we also have functions over here to the right. These grids here represent the different grids that can be used for expressions that have already been loaded up into the project. So if I go ahead and close this and click on the grid data, what we're seeing here is a number of different grid data sets. So I believe percolation was one of them, as well as moisture deficit. There's two grids there, and then percent impervious. There's the fourth grid. Not every grid is available for every calculation. All right, so let's go back to the transform method, mod Clark, and then the expression calculator. Okay, so for time of concentration, what we want to do is select stats. And then the website gives us the expression that we're supposed to be using for this particular subbasin. And it's right here in step E. So 1 and 2 are the equations for time of concentration and then the storage coefficient. It says that the time of concentration is 2.2 times this large quotient raised to the 0.3 power. This particular equation is not universal. It was specifically designed for these subbasins. L in the equation represents the flow path length in miles. L sub C represents the centroidal flow path length in miles. And then the denominator here, slope 1085, is the 1085 slope in feet per mile. So I'm going to minimize that and then put that expression into our expression calculator right here. So again, time of concentration, I'll start with 2.2. So we'll type that in and then times. And now I'm going to need to raise this entire expression to a power. So the power function over here, I'll double click that. Okay, so the exponent is going to be 0.3. And then the base is going to be this entire quotient here, open parentheses, and then longest flow path in miles, which is double click right here. Okay. And then after that, I want to multiply that by the centroidal flow path in miles, which is this one right here. Now I need to do a close parentheses and then divided by then another power function for the square root. So I'm going to just double click on power again. Okay, now we have base comma the exponent. So I'm going to just go 0.5 for the square root. And then this base here is going to be the slope, 1085 slope, and that's in feet per mile, is this one right here, I believe. So that pasted in, but I need to take out this word base because that's just a placeholder. Alrighty, I think I'm good. I think I need one more close parenthesis here though. And then let me click calculate and see what happens. Okay, it's calculating and I have okay, so I'm missing a closed parenthesis somewhere. One second. Okay, I think I found the problem. I think I needed to add a open parentheses right here. And then let's see what happens when I click calculate. And actually, before I do, let me just move this out of the way because what should happen in the table is that if it's successful, those values should automatically pop into place. Let's click calculate and boom, there we go. So we now have our time of concentration values that are calculated and populated into our three subbasins automatically. So it's a lot quicker than individually clicking on a subbasin in the basin map and then typing in an individual number for that subbasin's time of concentration. We're also given the expression here for the storage coefficient, R, in hours, and this is just equal to the time of concentration conveniently. So what we could do is just change this field to storage coefficient and then use the same expression. So we could just click calculate and then boom, the same numbers pop into place right there. The tutorial also tells us that we can change this expression precision or significant figures really is what it is if we go to the tools menu, so I'm going to go ahead and close this, and then let's apply and close. So if we go to tools, program settings, and then compute, this value here, expression calculator precision, is currently set to 3. But if I wanted to make it larger, it could go up to 5. So I'll just leave it there. Okay. Now, if I click on one of the subbasins, say this Mahoney Creek subbasin, and I go to the transform tab, I now have those values populated, 712 and 712. The other subbasins also are populated with data. All right, next we need to populate the actual data for the parameters for the loss method, which is going to be a deficit and constant loss method. So just as with the transform method, we're going to go up to the parameters menu. This time we're going to go loss, deficit, and constant. I have one of my subbasins already selected, so that filter is already selected. So what I want to do is just say no filter. Okay, there we go. Now I'm seeing what I expected to see, the 3 subbasins, each with their 4 parameters for the loss method. As before, with the transform method, none of the data is initialized, and I believe this is 0 for percent impervious is just like a default value. So the next step is to click on the calculator to bring up the expression calculator again. This time we have 4 different fields for the 4 different fields that are associated with the deficit and constant loss method. So let's just do these one at a time. The first one is the initial deficit. Instead of using the stats variable, this time we're just going to use the grid variable. And lucky for us, this project was already populated with the exact grid data that we want right here. So for initial deficit, I'll click on initial deficit. In fact, I'm going to double click initial deficit, and that will populate the expression calculator window down here. And all I have to do is click the calculate button, and then that will populate that initial deficit value for all 3 subbasins. As you notice, we now have the 5 significant figures that popped into place due to the change that I made there in the program settings. We're going to repeat this process for the 3 other parameters just by selecting minimum storage now. So let me delete the expression down here. Sorry, maximum storage, which is maximum deficit. And then double click that maximum deficit grid and then click calculate. All right, 2 down, 2 to go. Next is the constant rate. That's the percolation rate. So we'll just double click that and then calculate. And then the last one will be percent impervious, which is this last record here, and percent impervious, and calculate. So I'll close that, click apply, and then click close. So that's how we can use the global editor, specifically the expression calculator, to quickly populate parameters for our subbasins. The tutorial also tells us to create and run the simulation and then view the results. In fact, I believe the simulation already had, yeah, we already have a simulation run for September 2018 that's been loaded in. So let's just go ahead and do that last step here. I'm going to just take a quick peek at it. We have a basin model, met model, and a controlled specification right there. So the controlled specification is going to be for a 1-hour time step for the first 28 days of September 2018. All right, let's go ahead and select that and then run it. So it's running the model right now, and then it finished. That looks good. And then finally, we're told to click on this results tab, expand the simulation run, click on our September 2018 simulation, and then view some of the results. So for instance, if we click on this global summary, we have a table here of our different elements, the drainage area, peak discharge, time to peak, and then volume in terms of inches. The calibration value is the next result down, and it looks like we're quite a bit off, but it's all right. It's just the first step. And again, this video and exercise was about populating the parameter values anyway. All right, well, that was it for this exercise. Hope that was helpful.